In this tutorial, we are going to evaluate the integral of xy squared dx plus x squared y dy along the closed curve C, where C is the triangle with the vertices 0, 0, 0, 4, 2, 4. So we want to evaluate that line integral along that triangle with those given vertices. So the first step, I'll draw that triangle, and I'll draw my x-axis and then my y-axis there, and go on and label the vertex 0, 0, then draw the triangle and label the other vertices 0, 4, and 2, 4. So that's the curve that we are given there. And usually when you are given curves of this form, it is better to split that curve into 3 parts, because we're having 3 different parts there. So let us split that curve into parts C1, C2, and C3. And I'll call that part C1, and then that one C2, and the other one C3. Our integral there has a small arrow, and that arrow is indicating that the orientation is counterclockwise. And for that integral, when you have split it, it will become the integral along the curve C1 plus the integral along the curve C2 plus the integral along the curve C3 of x y squared dx plus x squared y dy. So let us now go on and evaluate the line integrals along those 3 curves that we have just said about. So along curve C1 there, we are seeing it's a straight line which passes through the origin and the point 2, 4. So to get the equation of that line, we know y is equals to mx plus c, the equation of a straight line. What we just need to do is to get the gradient of that line. Since it's passing through the origin, the c will be 0. So for the gradient of that line, it will be the 4 divided by 2, the coordinates that are at the other endpoint. So the gradient of that line will be 2. So the equation of the line on C1 there is y is equals to 2x. And if it's y is equals to 2x, then we can differentiate that. And when we differentiate it, we get the derivative of y with respect to x is equals to 2. And then from there, we get that dy is equals to 2 dx. And then to evaluate our integral along the curve C1 of x y squared dx plus x squared y dy, we now take those values of y, which you said is a 2x, and the dy, which you said is 2 dx, and put it in that integral. Along the curve C1 there, we see that x is varying from 0 to 2. So our limits of integration are from 0 to 2, and that integral becomes the integral from 0 to 2 of x times 2x squared dx plus x squared times 2x times 2 dx. And that will simplify to the integral from 0 to 2 of 8x cubed dx. The integral of 8x cubed there, it will give us 2x to the power 4. And when you put in the limits there, we'll get that value will be 32. So the integral along curve C1 is a 32. We can now move on to the integral along the curve C2. Along curve C2 now, what we are seeing there is y is a constant, it's a 4. And if y is the constant, then dy will be a 0. And we are moving counterclockwise. So our x is changing from 2 to 0. And then to evaluate along the curve C2, x squared yx dx plus x squared y dy, we substitute the values of y equals to 4 there, and our dy equals to 0, and the limits, and we have the integral from 2 to 0 of x times 4 squared dx plus x squared times 4 times 0. And the part that is times 0 there, it will be a plus 0. So we'll remain with the integral from 2 to 0 of 16x dx. And the integral of 16x with respect to x there, it gives us an 8x squared. And when you put in the limits, we get minus 32. We are now left with evaluating the integral along the curve C3. So along C3, what we see there is x is 0. It's not changing. Therefore, our dx will be 0. And our y is varying from 4 to 0. Remember, we are looking at it moving in the counterclockwise direction. So y is varying from 4 to 0. And then we go on to evaluate the integral of x y squared dx plus x squared y dy along the curve C3. Our limits, how we said, is from 4 to 0. So it will be the integral from 4 to 0 of 0 times y squared times 0 plus 0 squared y dy. So that part will just give us a 0. So the integral along the curve C3 there is 0. And now to evaluate the integral along the curve C, it's a combination of those 3 line integrals. And we get it will be 32 minus 32 plus 0. And it will give us a 0. So what we are having there is that the integral of xy squared dx plus x squared y dy along the curve C is equals to 0.